Solving exponential like this, 4 to the power of x equals 9. Now the problem here is we can't raise 4 to a power, an integer power, to get 9. And even if we take this to the base 2, we can't get up to 9. So this is where logarithms come in handy. So the first method would be just to rewrite this as a log base 4. So this is log base 4 of 9 is equal to x. And we could work out what log base 4, rewrite that so it's a clearer 4, log base 4 of 9. We could definitely do that. Another way to approach this, which is, for this simple one is not necessary, but when we get to some more complicated ones is a more useful strategy, is to solve this as an equation as we would any other equation, which is do the same thing to both sides. And in this case, what we're going to do to both sides is we're going to take log base 10. It doesn't particularly matter which log, but we'll do log base 10. So if we take log of the left-hand side and we take log of the right-hand side, equality is maintained, as long as we do the same thing to both sides. Now we can use laws of logs to bring this x out the front. And then dividing through, we get log 9 over log 4. Now, we know that these two things are equivalent because we've seen the change of log rule, which says these two things are the same. My point here is, whilst this red method is very quick, it only works in these very simple cases. Once the cases become a bit more complicated, in particular, when you have powers on both sides, you're going to have to use the blue method. So it's certainly worth getting used to doing this method to solve these types of equations as we build up towards more complicated ones.